Greetings and welcome to the Plsql channel, a series of video trainings on the Oracle Plsql language. My name is Stephen Feuerstein, and I'm a Plsql developer just like you. This lesson is part of my series on error management in Plsql, and in fact, it is the last section in this lesson. And the title of this one is Best Practices for Error Management with a focus on standardizing error management with a shared utility. Some quick reminders. First of all, if you haven't already, visit my Plsql obsession site, toadworld.com/sf. You can download all the code and PowerPoint documents for this lesson and pretty much all of my trainings. Make sure you're comfortable with the material covered in the previous lessons in this series, how to define, raise, and handle exceptions, continuing past exceptions, and also the first section on my best practices. So, standardizing error management, the agenda. First of all, I'll talk a moment about why standards are critical for error management. I'll move on to some key principles driving setting the error-related standards. And I'll talk about how to implement the standards. And what I'm going to do is use the Quest Error Manager, a freeware tool available from Quest, as a model and guide for basically implementing or following the principles. And just a note, this is not intended to be a training on QEM. I will be demonstrating its usage, but you'll have to download the utility and use the resources there to learn how to use it more fully. Really what I'm doing is using it to emphasize the concepts that I used to create a utility like QEM. So error standards, they're critical. In general, the more standards we have in our environment, the better. We end up with more consistent, more easily maintained code. So we should almost never say no to standards. We should ask our managers to give us more standards. But error-related standards are especially important because when things go wrong, users are affected, development plans are disrupted, and it's time to drop everything and put out the fire. So the reason that then standards around error management are important is that they will help you deal with the situation and make the recovery process as smooth and rapid as possible. The problem is that error standards are often avoided or at least just not done. And I think the problem there, or part of the problem, is that we don't like to focus on the negative. We focus on and spend a lot of time getting our programs to work right, the positive side of things. And to focus on the negative right up front while we're implementing the main logic of our code is difficult. It involves a psychological switch. And so we instead at least say to ourselves, we'll do that at the end. We'll come back to our code and add exceptions, but no, that usually doesn't happen. And of course, we might talk about writing code that handles the normal requirements. In other words, we say to ourselves, well, errors shouldn't really come up from this code. Well, that's a really crazy thing to say about our code, right? We should expect that errors will occur anywhere, if only because what we think is the normal expected behavior usually doesn't match what's going on in the production environment. Things will go wrong. How is our application protected or bulletproofed to handle that situation? So without standards-driven development for error management, you can end up with exception sections that look like this. Now, I cover and analyze this particular piece of code and its problems in the best practice lesson 1, so I'm not going to do that again. But clearly, we have a mess on our hands, and the mess is a lot of hard coding. So we've got the -2984, we've got hard-coded messages, hard-coded program names. We also have an exposed implementation of our error log. I'm showing you right in this code what I'm doing with my errors, where I put them. And if anything ever changes, I have to go back and change all these different insert statements. And the other thing to notice about this exception section is that it just took a lot of time to write. And we don't want to spend a lot of time in our exception sections writing all this code. So this is a very messy situation, very difficult to understand and especially to maintain. So let's talk about some key objectives for error standards. First of all, the main thing is that everybody writes error management code in the same way. You don't write inserts into log tables while I write inserts into files to log my situations. We have to have a consistent way to communicate back to the users through, for example, raise application error and the -20,000 error numbers. We should all do it the same way so that if I pick up your code and have to look at an exception section and make changes, it makes sense to me. I can understand it and I can make changes without having a heart attack. Second, let's find a way to minimize the time spent by the developers in the exceptions section. Let's face it, you are not paid to write exception code. You are paid to implement user requirements. You want to spend most of your time there. And finally, we need to figure out a way as part of the design and setting of standards to allow for full capture of system and application clues as to the source of the problem. This is one of the areas of great weakness in the Oracle architecture that I will go over in this lesson. But we want to gather all this information, basically, what was the state of the application at the time the error occurred, to make it as easy as possible to reproduce and then resolve the issue. So I think any standards that we write and the way we implement those standards has to meet these objectives. It has to help us write consistent error logging code, error management code, make it easy for us to do it really quickly, and allow us to capture everything we need to quickly fix the bug, resolve the issue. How do we meet these objectives? First of all, it comes down to communication as a team. Before you start writing your next application, sit down together and ask yourselves at least these questions. Where should we log the error information? Should we write to a table? Should we write to a file? And by the way, if and when you write to a table, don't forget to use autonomous transactions to make sure that that log information is saved. How do we handle deliberate, unfortunate, and unexpected errors? I talked in the last lesson about the difference between deliberate and unfortunate. Unexpected is a hard error. You have no idea it was coming, and you've got to basically trap it and propagate it out. You should look at these different categories of errors and decide how you want to address each one. Again, go back to lesson 1 for a discussion about deliberate and unfortunate. How do we communicate errors or information back to the front end? How do we decide what our users should see and how they can deal with that information, how they can provide information to support, etc.? And then, I think this is a very important question. Look at the information that Oracle can provide, and then ask yourselves, what information do we have to provide in addition to that in order to make sure we have that complete picture? Once you've gotten answers to these questions, and there are probably others that will come up as you talk, then you need to figure out how to implement these answers as thoroughly as possible with reusable shared code. In other words, there should be a single answer in general to the question, and then you should have a single implementation in code to allow you to answer that question. So let's focus in a bit more on a couple of the principles, and then I want to talk about the example that I've built following these principles, the Quest Error Manager, demonstrated to you, and go from there. So the bottom line is that every developer has to decide where and how to log the error. Do I write into a table? Do I write into a file? What information should I save? Do I need to call that DB mesh utility format error backtrace? Oh, that's a lot of work. What developers will end up saying to themselves is, well, I'm going to avoid doing that. I'm going to avoid writing those exception sections, or maybe I'll say when others then write something out really quickly to some table and get back to work. It's a disincentive for writing high quality code. So basically, instead, a developer should know that you call program A, a certain program, to do the logging. You call another program to do the raising. You call this program to get the error information out of the underlying repository. It's all decided in advance, making it really easy to do quickly. And one of the things you might also consider doing is using the templating capabilities in your own editors to create templates for common scenarios. When no data found comes up a lot, so why not have a template for exception when no data found, for an exception when others, that call your underlying error management utilities. All of these will help you improve the productivity of a developer when they dip down into the exception section. Second, capture system and application data. Now, in earlier lessons in this series, I talked under handling exceptions about a number of functions, most of them inside DB mesh utility, that will help you get key system information. What is the error code for the current error? What is the error message or message stack? What is the call stack? Show me how I got to this point in my code. And backtrace to a line on which the error was raised. These are all really important functions. They should be used, they should be called whenever an exception is handled. Now, of course, the question then is, do you have to do that all yourself? Or maybe we can have a program do it for us. But in any case, you need to make sure that you take advantage of all this stuff. Then the remaining challenge is developers have to be able to easily register application-specific data as part of the error logging process. In other words, so we've got the DBMesh utility error stack, call stack, format error backtrace. But what was the value of a salary variable? What was the name of the employee I was working with when the error occurred? I can't get that from Oracle, so I have to figure out a way to register it, save it myself. Okay, so that kind of sets the groundwork. What are the kind of challenges you face? What's the kind of information you want to gather? Let's talk about how to go about building a reusable error manager and then demonstrate the Quest Error Manager to you. So my driving principles when I went about building the Quest Error Manager were essentially two. One is to fix the limitations of the exception data type. In an earlier lesson called Defining Exceptions, I talked about the exception data type and how useful it can be, but also how limiting it is, and I'll demonstrate what I mean by that in just a moment. Second, do as much of the work as possible for developers. Again, we want to make it easy, minimize the time spent in the exception section, so the underlying manager should do as much work as possible. And that's what I used to design and build the Quest Error Manager. And just before I head over to that, the Quest Error Manager. So this is a freeware utility that implements the ideas that I'm going to talk about, that I talked about in principle above and below. And what you can do is go to the Plsql Obsession website, toadworld.com/sf, and then go to the Quest Error Manager link. So here's the Plsql Obsession site. Under Products and Utilities, click on Quest Error Manager, and you'll be able to download the tool. Now this is a freeware utility. It is not supported by Quest, but I support it because it's used in some of our back-end production code at Quest, particularly in the Quest Code Tester. So if you have any problems with the tool, you can get in touch with me directly. There's also an online community where you can post your questions and comments. So it's all there for you to use. It's all free. And the Quest Error Manager implements an error instance table-based repository that allows me to store all that information about what's going on with my application. And I'll demonstrate that to you. And a high-level API, a series of programs, procedures, and functions that allow me to raise and handle exceptions and communicate them back to the host environment. So let's talk about this idea of fixing the limitations of the exception data type. So when an error occurs, what information do we get from Oracle? We get the error code and we get the error message, and that's it. And sometimes the error message has some specific information. Sometimes, and mostly, it's very generic. Now, I suppose it's nice to know that the error number is -1855. But what I care about most is not the error number and the generic message, but what caused this particular error to be raised. That got me thinking in terms of instances of an error. In other words, it's not the -1403, it's not the no data found exception that's important, it's what caused it. And specifically what that almost always means is what were the application specific values, the context in which the error occurred. This seems to me to be the most important information to gather. And again, Oracle, from its generic interface, its low-level code, doesn't give us access to this. And in fact, there's no way to add additional attributes onto the exception data type. That's the weakness of exception. It's got a code, a message, and you can't add anything else to it, which you could do, for example, if you were working in a language like Java, which allows you to create subtypes of the general exception type. Well, the exception is not an object in Oracle. You can't extend it with other attributes. So what can we do to make it easy for a developer to save all of that critical information? So this is the thinking that I went through as I thought about building the Quest Error Manager. And what I did was do two things. One is I created a set of tables that serve as a repository for error information. And second, I built a package to manage those tables. So I have three tables: error definitions, error instances, application context. The error definitions table essentially allows me to define application-specific errors and also override the default messages for Oracle errors. So I can actually log in this table any application errors, and this is similar to the message info table that I talked about in Best Practices Lesson 1 about how to avoid hard-coding raised application error codes. So it's the same kind of idea, a repository of my errors, but also to override default messages. The error instances table records information about every instance of an error that occurred. In other words, in an application, when an error is raised and I log it with the error manager, a row of information is sent to the error instances table. Application context, this allows me to store any number of name-value pairs for a given instance of an error. So in addition to the Oracle generic information, I could say, let's add the name of the company. Let's add the ID for the employee that I was working with. Let's add the salary value that I just computed in a local variable. And it passes it to the back end and saves it there. Let's take a look at these tables. Now, again, the idea is not to go through an exhaustive, detailed explanation of the Quest Error Manager, but to give you a basic sense of the approach. So what you'll see is these three errors, the error, error context, and error instance. The $log is a part of the Quest Error Manager tracing facility, which I won't get into here. So the Quest error table allows me to set up categories of errors, just like Oracle does in its numeric ranges. The error code, the name, the description, substitution string, and recommendation. So here's an example of some of the bells and whistles you can add into these kind of generic utilities. The error string is actually a substitution string, so you can dynamically substitute variables with their actual values. I'll demonstrate this in a moment. Recommendation is you could add a message saying, okay, you had this problem. Here's what we recommend you do to try to get around the problem to fix it. So this way your error repository can be used to inform the user in real time of how they might be able to fix their problem. These are the rows of data that are inserted when you install the Quest Error Manager. I've got a number of different errors defined for Oracle errors. So that means that I have an override error message in my substitute string. And then I have some additional ones with the big positive numbers. These are the error codes that I just chose for my application-specific or generic errors. So you can populate that table as you wish. The error instance table contains information about each instance of an error. So the error ID, which is just a sequence, error stack, the call stack, error message, the error code, and so on. This is actually no error. System error code, that was an application-specific error. And the error context are the name-value pairs that allow me to keep track of. The first name in this case was Jennifer. I have to take a look at these, created on and by. It looks like they're not getting populated, at least in this demonstration scenario. I'll make sure that the triggers are defined. But usually you would see when it was created, who created it, and so on. But the main thing is the name-value pairs. So those are the three tables I've created to allow me to capture this information. Let's take a look at how I apply them in my environment. So what I've done is build an API in my Quest Error Manager package. And there's a lot more than these four, but these are the four we'll take a look at in the context of this lesson. Number one, register an error. This basically is the same as logging an error. I want to register the fact that an error occurred. Raise error says, well, register the error, save it out to the table, but then re-raise the exception to stop the calling block from continuing. So if you only want to log an error and not re-raise it, you call register error. If you want to log the error and then propagate it back out, call raise error. Add context allows me to add name-value pairs to a specific instance of an error. So that's all of that, those first three, are for putting information into the repository. But of course you need to get the information out. Now you could just write some queries against those underlying tables, but I've also created a separate program or a series of programs called getErrorInfo that the front-end code, like a Java program or a .NET program or even another Plsql program, can call to retrieve all the information associated with the current error or a specific error instance. Now, in addition to that, the Quest Error Manager package offers tracing capabilities, substitutions for dbms output.putline, and assertion interface. There's a lot of stuff in there, and we're not going to go over all of it here. It's not appropriate, but you might want to check it out when you have some time. It's called $Error Manager. Let's see if I can find it here. Here we go. The Error Manager package allows me to actually send my information, my log information, to a table, to the screen, to a file. You actually have a lot of flexibility in where your output goes. The PL programs are substitutions for dbms output.putline, so you can display many different kinds of information that the dbms output.putline doesn't support. A bunch of tracing programs. And then we've got the register error programs, add context, name value pairs, raise an unanticipated exception, and so on. So again, lots of stuff here. Here's a series of all the overloadings for getErrorInfo to retrieve the error information, which I'm about to demonstrate to you. So the point is, there's a lot of information here, and you should spend some time looking at the documentation, looking through the code specification, and then you can put it to use. But let's take a look at an example about how you might apply this Error Manager API. So the idea is that when you use the API, especially when you're handling an exception, you let the application developer specify the information that only they can provide. In other words, the application developer does not call DBMS utility format error backtrace. Why would you do that? You can have the underlying code do it for itself, and you'll see that in the Quest Error Manager package body. But the Quest Error Manager and Oracle in general is not able to say that in your program, the L_salary variable, that one's really important. Grab that. There's no way to do that. You as the application developer have to say to yourself, this is the information that's important at this point. I'm going to write it out to those tables so we can look at it later. Then support and the front end can retrieve the data, give better information to the users, and make it easier to figure out what went wrong. So let's take a look at a demonstration. So in the demo zip file, you can download the QEM demo file. And what I'm going to do here is take a look first at the kind of information we get when we just use the plain old Oracle information, then what we see when we use the Quest Error Manager. So I'm going to create a little demonstration table with 2 columns, department ID and salary, and I'll insert a row into that table. Notice my department ID is the primary key, which means it has to be unique. Here's my program, HR insert. I take the department ID. Using that department ID, I calculate the maximum salary. So I've got a formula inside my program to calculate the salary value. And then I'm going to try to insert it into my table. This will work. It'll do the insert as long as I don't already have a row in my table for that ID. But look at that. I'm going to call this program, and I'm going to actually do an insert for that same row that exists. Let's grab that code and try it out. Create the table, create the procedure, run my program. And notice there's no exception section. So I get an unhandled exception, which allows us to see right away the kind of information that Oracle provides to us. It tells us you had a unique constraint violation. There's the name of the constraint. Now, of course, you would likely have a real name for the constraint, like primary key for the table. So you as a developer could tell, oh, there's a problem with a duplicate primary key. Wow, how did that happen? But from a user standpoint, this information is bewildering, not particularly helpful. And that's it. That's all we get. There's no information about what the primary key value was, for example, that's causing the duplication. So this is not really that helpful, and in fact can be quite bewildering and scary to your developers. Now let's take a look at what I'm going to do with the Quest Error Manager. Instead of not having an exception section, or doing a very quick logging of the format error backtrace, the format error stack, what I'm going to do is trap my exception. And I'm going to say to myself, well, something went wrong, and I don't know what it was. It should have done the insert properly. So I'm going to raise the unanticipated error. So Quest Error Manager dot raise unanticipated. Now I could provide an error message here, but instead I'll just use the default, whatever the error message is that's a part of this error code. But what I am going to do is log all the different elements from the context that I think might be relevant in recovering from the error and understanding the error. Now, in the interface to raise unanticipated, what I've done is create the ability to add up to 5 name value pairs. I know that the interface here looks kind of awkward, but I find that it's the easiest way for a developer to quickly throw stuff in. Chances are you're not going to have 25 variables you want to store. If you do have that many, you can call the add context program to add some more. And I could overload this to add just pass a collection, but then you have to populate the collection. So while this looks kind of clunky, I think it's actually very useful in terms of being a quick way to pass values. Now, what values am I passing? Well, I want to pass in the department ID. That was my parameter. I want to pass in the maximum salary. Those are the 2 pieces of information that the backend can't know is relevant, but I know is absolutely critical. In addition, I'm going to tell it I was trying to do an insert into the departments table owned by the current schema, and that's the name of my constraint. I'll show you why I'm adding these as well. But again, it's other information that's relevant to the particular error. Then I'll run my application. But in this case, I'll trap the exception. I'll call the get error info procedure to retrieve the error information, and then I'll display it. So I'll show the error code, the error name, and the error text and error stack. So all this information, as you can see, is made available through this API. I'm not writing queries against the tables. I'm not calling DBMS utility format error backtrace, etc., etc. It's doing it all for me. I just call these programs. So let's try it out. And let's see what I get. Okay, so the error occurred. The code was -1. That's the dupe valid index. Internally in my error table, $errors, I called it duplicate value. It doesn't really matter what the name is, but what matters is what kind of message the user sees. So let's take a look at this. It's actually really long, which is probably not a big surprise since this was written by a guy who's written 10 books on the Plsql language. So here's the message that a user would see. And what I basically did was override the default message for -1, which is not very useful, to explain a little bit more simply and directly what might have gone wrong. And notice, as a part of this, I have substitution variables. So basically, in my underlying table, this used to be $table name. And when it was time to create the string, my backend code in the quest error manager said, do I have a name value pair with the name table name? I do. So I'm going to grab departments, put it in here. So when the code is actually run, or sorry, when we call get error information, instead of seeing a generic, we found an error occurring on a table, it says this table, owned by this schema, this unique constraint name, or this constraint name. So all that information is put into the generic error message with substitution variables, making it more relevant, hopefully more useful to the developer. After that, we see all the name value pairs that were not already used in the message. And then finally, there's the error stack pointing to the line number on which the error was raised. Now, the reason I'm pointing out all this cool stuff like substitution variables and showing the name value pairs is not because I want to boast about how clever I am that I could do this. I don't think it's a particularly clever utility. The point here really is more that when you're writing a generic utility, something like the quest error manager, you can take the time to do it right, to add some bells and whistles. If you were writing your exception handling logic over and over and over again, you would never take the time to do this. I sat down and wrote it once. I could put in some really cool stuff like substitution variables in your error messages. And then you choose whether or not to take advantage of it. But the main point, the main thing to think about is that as the application developer here, all I had to do was say, I know I call this program, and then I asked myself, what's important to store? What do I know about this program that other people would not know? And I put those name value pairs in place, and that's it. And then on the front end, the Java developers, the .NET developers can build a single widget, a single UI widget that calls get error information and displays all this information. So whenever an Oracle error is propagated from the back end, rather than writing all sorts of different kinds of error code on their side of the world, they can invoke the single UI widget for Oracle errors, display the error information, providing a very consistent display to the users, making it easier for them to understand what went wrong, and then how to report the error, or maybe even how to address it themselves. So hopefully that gives you a little bit of a sense of the power of having a common shared API, so I can easily dip down into the exception section, write some great exception handling code without having to do very much myself, and get so much more information stored as a result. So, some conclusions. First of all, very important, set standards before you start coding. Exception management is something that you know you will be doing. And if you do it ad hoc, or if at the end of the process you say to yourselves, now we need to go back and add exception sections, it's much more difficult to do. Next, use standard infrastructure components. Once you decide on your standards, build or find a utility that meets those standards so that everybody in all your programs handle errors in the same way. The Quest Error Manager, I think, is a pretty good offering to you if you don't already have one. There's also a shared logging utility on Oracle Technology Network that will help you do logging. So there are a number of options available out there, and I offer mine to you as a free utility. Finally, and this is a very high-level principle for me, don't accept the limitations of Oracle's current implementation. Oracle writes some amazing technology, but it's not always perfect. So the exception data type is kind of limited. They could have done a better job. Okay, fine. We can't change that, but we can build a layer of code around it to basically get the same effect, to add some additional attributes, store additional information with the exception. So the next time you hit a problem where you say to yourself, oh, this Oracle implementation, it's really not great. I need some other functionality. Ask yourself, can I build my own layer of code on top of Oracle's code that will allow me to get around these problems? And if you do, you've got a really nice utility that you've built, and also you feel fairly empowered as to what you're able to do with this technology stack. Next steps. First of all, if you have not already, download the demo zip file, which you can find on the main page of PLSQL Obsession right here. Download demo zip, go back through this presentation, try out the sample code that I reference, try out the demonstration of the Quest Error Manager after you've installed it, and make sure you understand the concepts and the specifics in this lesson. And if you haven't already set standards for error management, do it. Call a meeting. Get it done. You really need to have that in place. And if you decide to use the Quest Error Manager, great. If you don't want to use that, maybe you have one of your own already. You might want to take a look at the Quest Error Manager and see if there are features inside the tool that you can apply or put into your own. So thanks for joining me on this lesson and in fact on the entire error management series. I hope you benefited from it, and happy PLSQL coding into the future.